there's basically 4 primary pieces of information. There's the pH. Actually, let's just go back. I'll just go back a slide. You can see, maybe you can see at the bottom. Here's acid base. Here we go. Here's our relationships. H3O multiplied by OH concentration is 10 to the negative 14. pH plus POH is 14. What this means is, of these 4 things, you only need 1 and you have all 4. That is critical. The College Board is not going to give you the information you want in an acid-base exercise. It's not going to say this solution has a pH of this when you actually need pH. It's going to say this solution has a concentration of this. And if you need POH, it's not going to give you the POH, it's going to give you the pH. And if you need the OH concentration, it's not going to give you the OH concentration, it's going to give you the pH. Because if you have any one of these 4, you have all 4 with this relationship. If you have pH, you have POH. If your pH is 3, what's POH? 11. If your POH is 9, what's pH? 5. If your pH is 0, what's POH? 14. See how this works? If your OH concentration is 10 to the negative 3, what's the concentration of H3O? 10 to the negative 11. If your OH concentration is 10 to the negative 7, what's H3O? 10 to the negative 7. If your OH concentration is 10 to the negative 5, what's POH? 5. If your H3O concentration is 10 to the negative 6, what's pH? 6. If your OH concentration is 10 to the negative 2, what's the pH? 12, exactly. So 10 to the negative 2 makes this 2, makes this 12. If I told you the hydronium concentration was 10 to the negative 3, then you know this is 10 to the negative 8, you mean that's 3 and that's 8. No, hold on. You mean that's 3 and that's 11. Or 6, or I say 8, 6, sorry, 6. 6, I don't know where I got 11. So that relationship, if you have any one of them, you have all 4. Capiche? Now, I've been using 10 to the negative and whole numbers for POH and pH. You can do that if they're not whole numbers. Okay. Whole numbers are easy, but they don't have to be whole numbers. So if your H3O concentration is 10 to the negative 4, what's the POH? Or sorry, what's the OH? 10 to the negative 10, making this pH of 4 and that POH of 10, and so on. So there you go. Okay. If your acid concentration is 1 times 10 to the negative 3, then the hydronium is 10 to the negative 3, and the hydroxide is 10 to the negative 11. And there you go. If this is an acid or a base? Sodium hydroxide, acid or a base? Base. So that would mean the hydroxide concentration is 10 to the negative 1, and the hydronium concentration is
negative 13.
10 to the negative 13. And on and on. Okay. So a solution with a pH of 3 is a pOH of 11. A solution with a pOH of 10 is a pH of 4. A solution with a pH of 4 and H3O concentration of
8. 10 to the negative 8.
10 to the negative
10.
4. It's H plus in both cases. If you have a pH of 4, you have an H0 concentration to negative 4. A solution with a pH of 8 has an OH concentration of 10 to the negative 6, exactly. Because that means the POH is 6 and the HO concentration is 10 to the negative 6. If you get hung up, watch the video. It's going to be on YouTube in about an hour. HO concentration is 10 to the negative 4, what's the pH? Okay, I'm going to put the rest of these online. I'm going to copy and paste the slide. I'd like you to take a look at Google Classroom and do the math, because eventually we're going to move away from 1 times 10 to the and whole numbers of pH, and you need to get the experience of banging into your calculator logarithms and anti-logarithms.
Mr. Byers.
Yes, yes. Oh, okay. Cameron, yeah.
So is polarity based, like